Hi, it's Mr. Krieger. We're in Unit 9 doing Lesson 2. We're really starting trigonometry now. This lesson is called Trigonometry Ratios, so make sure you have the lesson. Okay, so definition. Trigonometry is the branch of mathematics that deals with the relationship between the angles and the sides of a triangle. Now, in the past, like when we used the Pythagorean theorem, we really only were dealing with the sides exclusively. Now we're going to see the relationship between the angle measures and the sides, and that's really what trigonometry is all about. These are a few important things to recall. First of all, you know what the hypotenuse. It's the side opposite the right angle, and it is the longest side of the triangle. The legs are the sides of a right triangle that form the right angle. In other words, this leg and this leg come together to create that right angle, okay? Now, here's what's brand new. This is something that we haven't talked about before. The opposite side. Now, opposite side of what? We're going to have to specify an angle. One of the acute angles, never the right angle, but one of the acute angles. And when we talk about an opposite side, we talk about the leg that's across from a specific angle. So I'll give you an example. Like, for example, if we're talking about A, and I'm going to circle it here, and we'll go over it again in a minute. But if we're talking about A, then this side is opposite from angle A. Angle's up there, this side's opposite to it. The hypotenuse is never considered one of the opposite or adjacent sides. The hypotenuse is always just the side across from the right angle. It's the longest side. We're talking about the side opposite from a specific angle. Here we're talking about angle A, and this side is, you could see, opposite. I'll put it in a light pen here, opposite from angle A. Now, the word adjacent literally means next to. So therefore, we're going to say an adjacent side is the leg that is next to a specific angle, not the hypotenuse. So if, again, we're talking about angle A, then this is the side adjacent to angle A, okay? So A is here, and this side would be adjacent. That side would be the opposite. And this side is the hypotenuse, which is never considered opposite or adjacent. It's always just the hypotenuse. But these two can change. You might say, how can something change from being opposite? Well, let's see. Okay, so the sides considered opposite and adjacent change depending on which acute angle is being referenced, which acute angle we're talking about. So for angle A, it was side BC that was opposite, and it was side AB that was adjacent. But if we go to angle C, acute angle C, and what I'm going to do is I'm going to make like a little bubble around C. So now we're looking at angle C. Now things are going to change. For angle C, AB is the opposite side, and BC is the adjacent side. Essentially, they've switched because we never look at the hypotenuse. From angle C, that side's opposite AB, and from C, this side is the adjacent side. So that's one of the key things to understanding trigonometry, knowing which side is opposite and which side is adjacent. As long as you can identify which side is opposite from one of the acute angles and which side is adjacent, you should be all right, okay? And this is another key note. The hypotenuse will not change. It will always be the hypotenuse. It's always the side opposite the right angle, okay? Now, what we're going to learn is these three new ratios. They're special trigonometric ratios, and they have funny names. You might have heard of these names before. They're called sine, cosine, and tangent. Like the word sine can literally be spelled S-I-N-E, but we usually use the letters S-I-N to abbreviate it. Cosine, we usually use the letters C-O-S to abbreviate it. And tangent, we use the letters T-A-N to abbreviate it. And What do these words mean? Really not much. All they mean is specifically what ratio are we going to be talking about. Like, for example, if we're going to be talking about sine A is defined as the length of the leg opposite from angle A. So if this is angle A, and if you recall, this is opposite, so that's BC. BC is going to go on top of the ratio. And then for sine, the hypotenuse always goes on the bottom. Now the hypotenuse is AC. So all sine is a ratio, something over something. Now usually there's going to be numbers there or an x. Here we're actually putting the names of the sides there. It's the opposite side from A, side BC, over the hypotenuse, AC, and that's all sine is. It just stands for a ratio of opposite side to hypotenuse, okay? Cosine of A is defined as the adjacent side to angle A over the hypotenuse. Now the adjacent side to angle A is AB. That's here. Over the hypotenuse. So cosine almost is similar to sine. It's adjacent over hypotenuse as opposed to opposite over hypotenuse. So the adjacent side is AB over the hypotenuse, which is still AC. So if you notice, the only thing that's different between the sine ratio and the cosine ratio is that the sine ratio has the opposite side on top and the hypotenuse on the bottom, and the cosine ratio has the adjacent side on top and the hypotenuse on the bottom. And finally, tangent doesn't have the hypotenuse. It's just the opposite side of angle A over the adjacent side of angle A. So the opposite side is BC, that goes on top. The adjacent side is AB, that goes on the bottom. And these are the ratios here, the abbreviated. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, okay? And you'll notice underneath I have these letters. And it's a shortcut. And in fact, this word helps you to memorize the ratios. Because what is sine? It's opposite over hypotenuse. So this word, which is just an acronym, the way we pronounce this word is SOHCAHTOA, where the sine stands for opposite over hypotenuse, that's this ratio here. Cosine stands for A, adjacent over hypotenuse, that's this ratio here. And tan stands for opposite over adjacent, that's this ratio here. So if you remember this word, SOHCAHTOA, you'll never need to look at these ratios. You'll know how to create them right from using this word, okay? Now, the thing to remember is sine and cosine and tangent can change depending on which adjacent angle we are looking at. Let's take a look at what we mean here. So let's do an example where we actually have numerical values on the side. So instead of calling a side KJ or KL or LJ, we'll put the numbers in the appropriate spots, okay? So the first thing we're going to do is we're going to talk about what the sine of angle J is. Well, remember what I told you to do? Let's make a circle around J so we know which angle we're referring to, which angle we're referencing. We literally call that the reference angle. Now we know sine is opposite over hypotenuse, O over H. That's from here, OH, opposite over hypotenuse. Now all we need to do is find a number that is the opposite side. So from angle J, the opposite side is going to be that 10. You see, I'm going to actually go across to 10. Opposite is 10 over adjacent, over hypotenuse. The hypotenuse is always the long side across from the right angle, so it's 10 over 26. That's sine of J. That's largely what trigonometry is, making these ratios. We're talking about the specific acute angle. This one we're talking about J. Then we're just doing opposite over hypotenuse. So you could try the other two, but I'm going to work on it, and you can pause the video and try them yourself. Cosine is adjacent over hypotenuse. Now remember, for J, the adjacent side is going to be this side, the LJ side. That's going to be 24. And the hypotenuse is still the same. That's going to be 26. And tangent of J is, as we see over here, opposite over adjacent. I'll call it O over A. Opposite is 10. Adjacent is 24. And we've made the three ratios: sine of J, cosine of J, tan of J. But now what's interesting is, let's see what happens is instead of using J, the acute angle J, let's now use acute angle K. So I'm not going to look at this angle anymore. And in order for me to keep track of where I am, I'm going to put that bubble around K so I know I'm looking at that angle now. So sine of K, remember, that's opposite over hypotenuse. But now from K, the opposite isn't going to be the 10 anymore. It's going to be 24. 24 over, sorry, that doesn't write so well. 24 over hypotenuse is always hypotenuse, so it's 24 over 26. Cosine of J is adjacent over hypotenuse, which in this case is going to be, from K. From K is adjacent is 10 over 26. Adjacent over hypotenuse from K, it's 10 over 26. And tangent we know is opposite over adjacent, but now we're going to be looking at K. So opposite is 24 over adjacent, which is 10. And that's how you set up the ratios. And as long as you remember this word and know how to spell it out, you should be able to set up all your trig ratios. Now I want to look at something. Do you notice any relationship between the ratios of the different angles? Specifically, look at this and look at this carefully. Pause the video if you need to. These values are the same and these values are the same. So watch this. We know that sine J is equal to cosine K, and that cosine J is equal to sine K. And we're going to look at this a little more at the end of the lesson. The sine value of one of the acute angles, sorry, I spelled acute wrong, is the cosine value of the other acute angle. I'm going to take a look at that more in a little while, okay? So that's an interesting relationship to see. All right, let's go take a look at the next page of the lesson. Here's some practice. So this will be an opportunity for you to try the problems yourself. There are going to be a couple of things you're going to have to be aware of, especially in that first problem. But you're welcome to pause it, and this way you can check your answers against what I'm doing here to see if you're doing it right. Always write down, since we should know this acronym, SO, CA, TOA, okay? And we're going to do sine x. So I'm going to I'll put a circle around the x. Sine is opposite over hypotenuse. Opposite is 3 over rad 13. Okay? Cosine of x, that's adjacent over hypotenuse. That's going to be 2 over rad 13. And tan is opposite over adjacent. I'll put O over H here. From x, it's 3 over 2. And there we've created the fractions for this. Now, in the previous lesson, you noticed that sometimes I like to rationalize denominators here. So let me quickly just show you what I would do for this. Let me find a place where I could write this on. Do it over. All right, I'll just do it up here. Suppose I wanted to rationalize the denominator for 3 over rad 13. I'd multiply by rad 13 over rad 13. That's going to become 3 rad 13 over rad 13 times rad 13 is 169. But the nice thing, the square root of 169 is actually 13, and that rationalizes the denominator. So for sine of x, you could get 3 over rad 13, and rationalized, it will look like 3 rad 13 over 13. Okay, just saying. Let's try to do sine y. Now let's go back to this triangle, and we're working at angle y. So now let's focus on angle y. I'll put a bubble around it. Sine is opposite over hypotenuse, but now opposite is that side, because from y, that's the opposite side. So we get 2 over rad 13. Cosine is adjacent over hypotenuse, so adjacent is going to be the 3 over the hypotenuse rad 13. And tangent is opposite over adjacent, so we're going to get, I'll put it over here, opposite over adjacent, 2 over 3. Okay? And now you might want to pause and try this problem on your own. I'm going to keep working on it. So again, this is the hypotenuse here. just to make sure you know that's the right angle there. So we're going to start off with angle D. I'll put a circle around it. Sine is opposite over hypotenuse, so the opposite is 7 over the hypotenuse is 25. Cosine of D is the adjacent, that's the 24 over the hypotenuse, which is 25. And tangent is opposite over adjacent, which is 7 over 24. From D, opposite is 7, adjacent is 24. Now from F, and remember we never use E to do trig ratios, we only use the acute angles, never the right angle. I'm going to put a little bubble around that so I can keep track of where I am now. I'm around the bubble. And sine is going to be opposite, which is 24, over hypotenuse 25. Notice these are the same. That's what we saw on the previous page. Cosine is adjacent over hypotenuse, which is 7 over 25. And finally, tangent is opposite over adjacent, which is 24 over 7. Okay, so hopefully you're getting how to make these ratios. Okay, last page. Okay, cofunctions. What are cofunctions? That's the last thing we're going to learn today. How do you solve equations involving cofunctions? Okay, using the given diagram, the relationship between angle A and angle B, what do you think the relationship is? I'll give you a hint. What about their angles? What do their angles have to add up to? They have to add up to 90. Angles A and B are complementary, angles that add up to 90 degrees. Now, the value of cosine of A in this problem is 3. Oh, actually, we need to use the Pythagorean theorem to find that side. A squared plus B squared equals C squared. That side's going to be 5. We could also call this a 3, 4, 5 right triangle. Okay? So cosine of A is going to be 3 over 5, which is the, adjacent over hypotenuse. Sine of B is opposite over hypotenuse, which is again 3 over 5. We saw this relationship before, but you'll notice that cosine of A has to equal sine of B as long as angle A and angle B are complementary. So if you ever see an equation that relates sine and cosine, sine will equal cosine as long as the angles add up to 90. Now this funny 0 here is actually not a 0, it's the Greek letter theta. So sometimes you'll see that Greek letter theta, and it's used to find a missing angle. So just like you have an X on the side of a triangle, sometimes they'll put that little symbol that looks like a 0 with a line through it to represent the missing angle. Like for example, if we wanted to find that missing angle, instead of putting an X there, we might put a theta there, because usually in trigonometry we'll use that theta to represent the missing angle. Okay? So what I want you to notice is that, take a look at this first question. Sine of theta is equal to cosine of 15. What would be the value of theta? Well, sine will equal cosine as long as the angles add up to 90. They have to be complementary. So if you ever see an equation where sine is equal to cosine, those two angles have to add up to 90, and you can solve that equation. That's that theta symbol. Minus 15 minus 15, and we're going to get theta is equal to 75. Okay? Now, I want to show you again. I know we've seen this before, but before we go and do more problems, I just want to emphasize this important to you. So I used a problem that we had before with one of the previous examples. I put the approximate measures of the angles in there. And notice that sine of 33.7 is 2 over rad 13. Cosine of 56.3 is 2 over rad 13. So sine from this angle, watch this, sine from this angle is opposite over hypotenuse. Look where the arrows are going. Cosine of this angle is adjacent over hypotenuse. Remember, the first arrows went to the 2, the second arrows went to the rad 13. As long as these two angles add up to 90, and I'll put that up here, 56.3 plus 33.7 add up to 90 degrees. As long as the angles add up to 90, then the sine will equal cosine. Here's the important thing. These are the angle measures. The angle measures will not be equal when sine is equal to cosine. The angle measures will add up to 90. Now, when you see an expression like this where sine of theta is equal to cosine of 90 minus theta, all this is saying basically whatever measure you have for theta, let's say it's 30, then 90 minus that 30 is 60. Sine of 30 will be equal to cosine of 60. Because when you put the theta into this formula, that's going to be the complement of this number. So your formula for solving these types of what we call cofunctions, sine and cosine are considered cofunctions. That's actually why one of the equations is called sine, and the other one is called cosine because they're co-functions, okay? All you need to know when you solve a problem where you see sine is equal to cosine is take the angle parts and add them together to 90, and then you can easily solve. So here we're getting theta is equal to 63. So you could try this problem. You could try all the problems, but I'll continue them. You could pause and try the problems just in case. So here we'll take the two angles. 3x is equal to, I'm sorry, that's not correct. 3x plus 12 equals 90. Here's one angle, 3x. Here's the other angle, 12. They have to add up to 90. Now, this one's a little more complicated than that one, but not really much more. It's just a regular, pretty simple equation to work on here. So you get 3x equals 78, and if we divide both sides by 3, we're going to get x is equal to 26. Okay, let's try this problem. All right, remember, sine is equal to cosine, so the angles must add up to what number? They must add up to 90. And then the solution's pretty easy. Combine like terms. And then you solve. X is 35. Okay, finally, last one. 2 theta. Don't put 2 theta equal to 3 theta. I almost made that mistake before. They add together to equal 90. And then you can simply solve that. Remember, this is not a 0. It's a theta. It's just like an x. Divide by 5, and you get theta equals 18. And that's how you do cofunctions. So make sure you work on the homework on this. And be prepared to have your graphing calculator. And if you don't have a graphing calculator, I'm going to share with you tomorrow a program on the computer that you could use because you're going to need special functions on your calculator. So I'll go over that with you in the next lesson.